Hi there, you're in the lab with your mate JJ. Today is Module Monday. It's Module Monday. My silly job title for today is Master Planner. Today I'm the Master Planner. The module for today is the digital Hall effect sensor. So last week we had a look at the analog Hall effect sensor, and this week we'll be looking at the digital Hall effect sensor. If you don't know, a Hall effect is a magnetism detector. So the component can detect the presence of a correctly polarized magnet. So what we'll be doing is popping over to the bench to have a look at the component. Then we'll jump over to the computer and see what information we can get about it. And then we'll pop back over to the bench and we'll build a circuit using it with the Arduino Uno. So let's jump over to the bench and see what we got. Here on the bench, and this is our box full of Hall effect sensors. In the front we've got digital ones, and in the back we've got analog ones. Of course, we already had a look at the analog one, so here is the digital one. Now it seems to have a potentiometer wired in there, some sort of a integrated circuit. I don't know what that is. It seems to have 4 pins, and they're labeled ground and positive, and then DO and AO. Interesting. So I'm not sure how to wire this up. We'll have to figure it out. Now, I might be able to show you the, yeah, here we go. So if I just put that up there, flip you over here, this is the circuit under the microscope. So you can see on the left-hand side there are the inputs or the outputs, the connectors. AO, G plus, and DO. Then the big blue thing is some sort of a potentiometer, and looks like a 100K pot is my guess. 104. It's probably 100K. There's some sort of a what does that say? I'm not quite sure what that says. And then there's the Hall effect sensor itself on the right hand side. And on the back, is there anything interesting? Not really. Just some circuit traces. So I might see if I can figure out about that. Oh, it's an LM393. Let's have a look at that. So I had a look at the LM393, and it's a voltage comparator. So that's cool. And that's obviously wired in with the potentiometer. So the comparator is used to turn the Hall effect sensor into a digital output. Cool. All right. Well, give me 1 second. All right. Well, I found the component that we've got. This looks about right. It's good that it's got the KY number. I like having that. So that's the KY-024 linear magnetic Hall sensor board switch. Speed counting Hall sensors module for Arduino DIY KY-024 Hall sensor. Very good. And if we scroll down a bit, there's specifications. Nothing really interesting there. Okay, this is an ad, and then this is the component. Product introduction. The linear Hall magnetic force module and the digital 1.3 interface have LED built in to build a simple circuit, and the magnetic field prompt lamp is made. Oh dear, that's not very good English. The LED built into the digital 1.3 interface is used to connect the linear Hall magnetic force sensor to the digital 3 interface. When the linear Hall magnetic force sensor detects a key signal, the LED will light up, otherwise it will go off. Okay, so basically they're saying use the built-in LED 13, sorry, for the output, and the input is on pin 3. That's what they're trying to say there. Product parameters, the LM393 and the 3144 Hall sensor magnetic induction probe, working voltage 5 volts. Very good. Product features, with signal output indication. Oh, there might be an LED on board. Yeah, that looks like an LED down here. What do you reckon? With mounting hole, convenient for fixed installation. Output valid signal is low level. Sensitivity adjustable, fine tuning. High sensitivity of magnetic field induction detection. Circuit board output switch can be directly connected to the single chip I/O port. Can be used for motor speed measurement, position detection, and other occasions. Okay. Looks pretty good to me. So let's go over to the bench. We'll wire this thing into an Arduino and we'll write a simple project and we'll see how it goes. All right, so here we are on the bench, and this is our Uno that we'll be using. We'll be using one of the digital. Oh, we've already got one over here. Very good. Now, I don't know what AO and D0 mean. I'm not sure. Let's just have a guess. So we'll put the power in. And we'll write a program. Yeah. Now I've got a magnet here somewhere, so I'm not sure. There we go. All right, great. So we've got our measurement working. Let's. I'll just. I'll be back in a sec. All right. So just wanted to show you the code. This is it's just one page of code. You can see it all there. The sensor pin is pin 3. The LED pin is 13. That's the onboard LED. And the sensor value, we just initialize it to 0. In the setup, we just set the output pin as an output. And I guess we should also set the sensor pin. This seemed to be working anyway, but we'll make it input, more input. All right. So in the loop, we just digital read the sensor pin and we print it out, and then we wait for 1 second, and then we just take another measurement. So I think it's Control U to upload. All right. Now we can see it's running there. You can see it just printed out a running statement, and it's reading 1. And the 1 means that the Hall effect sensor hasn't been triggered. So I'm just going to bring the magnet into the proximity, and we should see the 1s go to 0. Yep, so that's dropped down there to 0 now. And then if I take the magnet away, it'll go back up to 1 eventually. Give it a second to settle. So that's interesting. There seems to be a little bit of hysteresis or something on the signal. Look at that. It's not going directly back to 1. It's pretty reliably 1 now though. So I'm not quite sure how you calibrate this thing. Let me throw you back over to the bench here. So as you can see, the LED, the top LED will go off when the sensor's in the field. And I couldn't quite figure out how the resistor calibrates the comparator, but it did seem to basically work. I suppose the other thing to tell you is the top pin is AO, is for analog output, and the bottom pin is DO for digital output. So what we haven't done in this experiment is have a look at the analog pin, but I would expect that would be very similar to the analog sensor that we looked at last week. So this one's got the digital output, and that's care of the comparator here and the resistor for tuning it. So I think that's everything there is to show you about this. I'll take you over to the farewell cam and we'll wrap up. And that's a wrap. So yes, today we investigated the digital Hall effect sensor. It was calibrated with a potentiometer, and it used an LM393 comparator to set the level for the for the Hall effect sensor. We used a magnet, we brought it into the field to affect the circuit. We wrote a very simple program that interfaces with the digital pin. We noted that there was an analog pin, but we didn't use it. So that concludes this experiment and this video. So I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.